read that when you get a chance. And then it says, what do you mean by trig ratios? Well, first and foremost, guys, trig ratios can only be done when we're talking about right triangles. It can't be done with any other type of triangle. It has to be a right triangle. Must, must, must. Now, I know someone's going to say, what about law of sines, law of cosines? Well, that's not a trig ratio. That's using law of sines and law of cosines. So trig ratio. So draw a right triangle. And this is how you dictate that it's a right triangle. You have a little square on that little vertex there. And when you were in geometry, they called this vertex like A, B, and C. So then little a creates, point A or angle A creates little a, point B creates little b, and point C here creates hypotenuse little c. And because I have a right triangle, there's a famous theorem. What's that theorem called? Do you guys remember? Yeah, Pythagorean theorem. So then there's something called SOHCAHTOA. It's an abbreviation or an acronym that helps us remember what is what. SOHCAHTOA. Say it with me, guys. SOHCAHTOA. No, not suck-a-toe. That's just nasty, guys. SOHCAHTOA. So one more time. SOHCAHTOA. Perfect. SOHCAHTOA. What that means, the S stands for sine, the O stands for opposite, the H stands for hypotenuse, the C stands for cosine, the A stands for adjacent, the H stands for hypotenuse, the T stands for tangent, and again opposite, the O, and the A stands for adjacent. And I'll zoom in. I'm writing it down. That's an N there. When I replay this video, I'm going to hear you guys, and it's going to sound so sad. It's going to be like, SOHCAHTOA. Like, have you guys slept? Hey, look, there's Mestodes, guys. We're talking about SOHCAHTOA. Okay. It's fun, right? I mean, well, yeah. All right. Sorry, guys. So here we go. You guys ready? So usually you can say vertex B, but I'm going to go ahead and write theta there. That's a theta. It's a Greek letter. And then, I don't know, what do you guys like, alpha? That's alpha. So I guess this is Greek letter, guys. That's an alpha. And it is a Greek letter. That's a theta. There's actually a movie where, well, you guys probably haven't seen it. So, I think it's like Stomp the Yard, and they're like, where are the thetas? Thetas. You guys remember? Okay. I just made a fool of myself. All right, here we go. So here's how you use it, guys. I'm going to go ahead and write sine. And it's always sine of something, right? So sine theta, that's equivalent. You can use the vertice as well, guys. You can say sine capital B. So sine of B. So what is sine of B? Well, according to this, it says OH, so opposite over hypotenuse. So we can say opposite, so little b, over the hypotenuse, little c. And there it is. That's it. See, was that easy, guys? So I can write, let's see, cosine of that angle, theta, which is the same thing as saying cosine of b. So cosine is adjacent over hypotenuse. So what's adjacent to theta? The little a. Little a over, what's the hypotenuse? C. Now, what does the word adjacent mean? It's just a fancy word for next door, guys. Why can't we call C next door? Well, C already has a name. It's called the hypotenuse. The longest side of a right triangle is called a hypotenuse. Leave it alone. So tonight, your job, well, I mean, it's not a real job, but if you have a little brother, little sister, give them a cookie or her and say, take this to the adjacent room and see what they do. Hopefully they'll use context clues and take it to the room next door. Watch it take it to the neighbors, right? That'd be funny. But yeah, so adjacent just means next door, guys. Cool? All right, next one, I'm going to write tan theta. So tan theta is the same thing as saying tan B, and tan B is opposite over adjacent, so B over A, and that's it. Oh, okay, when I say opposite, okay, some of you guys are like, what? When I say opposite, here's the angle. This is what I mean by opposite. What's opposite of it? See? That B. Cool? And then what's adjacent? The A. The C is already called the hypotenuse. All right, guys, let's go ahead and use another vertice. Let's use vertice A, and we're not going to say alpha. We're just going to go right into it. So let's see. I'm going to write it here on the side. If I say sine of A, so let's see. What's opposite of angle or of alpha there? Little a over c. There it is. What is cosine of A? Cosine of A is going to be what over what? Oh, man. Not everyone at the same time, guys. And then tan of A, and it's okay if we're wrong. It's perfectly okay if we're wrong. Tan of A is opposite over adjacent. What over what? Yeah, A over B. Good job. There it is. Easy, right? Okay. Are there other types of trig ratios? Yes, there are other types of trig ratios. They are called reciprocal. So I'm going to try to spell it out. Reciprocal trig ratios, guys. Who knows those? Well, besides you two. You guys remember? That's how you spell them. Cosecant, secant, and cotangent. And when you abbreviate them, here's how you abbreviate them. Cosecant is CSC, secant is SEC, and cotangent is COT. You might see those buttons on a calculator somewhere. And when I say they're reciprocal, what happened there? When I say they're reciprocal, what does the word reciprocal mean? Yeah, just flip. So let's go ahead and continue to reference this right triangle right here, guys. So I'm going to say cosecant of B. Cosecant is the reciprocal of sine. So I look at sine and I just flip it. C over B. See? I'm going to write secant now. Secant is the reciprocal of cosine. So 1 over cosine, which means C over A. And then finally, cotangent, COT, is the reciprocal of tan, which is just A over B. Sorry, guys. Now, let's see if we can do the other one, guys. If you want to go fast, go for it. See if you can do it before I finish here. Cosecant of A. I'm looking at the same right triangle. Cosecant of A is the reciprocal of sine, C over A. Secant of A. Secant of A is the reciprocal of cosine, so C over B. And then cotangent of A is the reciprocal of tangent, so B over A. How are we feeling? Do we feel okay, guys? All right, here we go. Now we're finally going to start some kind of fun stuff. It says find the exact value of tan A. Now we're going to do this without a calculator, guys. See if we can figure this out. So I look at A and I put a little point there because I want to know which one I'm looking at. And then I write SOHCAHTOA on the side, SOHCAHTOA. And then I go, okay, this is tan. So I look at tan, and tangent is what over what? Oh, am I losing you guys? Yeah, opposite over adjacent, guys. So I just go over here and I go opposite. So I'm going to write tan of A is equal to square root of 28 over adjacent, which is, now there's a better answer. Oh, adjacent to A is 6, right? Okay. There's a better answer. Chavez, this is correct. What are you talking about? Opposite, adjacent. There it is. Yes, but the square root of 28 can be broken down. So hopefully you remember, without a calculator, without a CAS, the square root of 28, or 28, is the same thing as 7 times 4. 4 is a perfect square root. So 4, you can rewrite this as 2 square root of 7 over 6. Now that you have that, guys, how many times does 2 go into 6? So there it is. 3. You're right. I like that. Tan A is equal to square root of 7 over 3. And you're done. Good job, guys. Was everything explained clearly, guys? I can't read minds, so let me know. Okay. Example 2. Let's go to the next page, guys. Once you turn beast, you no longer have to write SOHCAHTOA. I would write SOHCAHTOA everywhere. SOHCAHTOA. And then I'm going to go, it says, find sine A. So I look at A, and I'm like, all right, sine A is opposite over hypotenuse. So opposite is square root of 63, and the hypotenuse is 12. And you leave it like that. I guess I would say okay, maybe put an awkward emoji. Is there a better answer? Yes, there is, guys. What's up? Oh, okay, sorry. Yeah, stop me, guys, if I'm going too fast or if you have a question. Is there a better answer? Yes, there is. Two numbers that multiply to give you 63. See if you can have a perfect square. If one of them, yeah, 9 and 7. The square root of 9 is? So 3 square root of 7, that's what you have left, over 12. And then how many times does 3 go into 12? So the best answer, guys, is square root of 7 over 4. Pretty cool, right? You guys are like, it's alright, I guess. Example 3. They didn't have to give us all this detail, guys. They did, but they didn't have to give us all 3 sides. If you read it, there are the 3 sides they give you, and they didn't have to. And then they tell us angle Z is 90, and it says what ratio represents the cotangent of angle X. So I'm going to write SOHCAHTOA again, and if you want to get ahead of me and you want to go on, go for it. So first I'm going to find tangent, because tangent and cotangent are reciprocals of each other. So I'm going to write tangent of X is equal to, here's X, tangent is opposite over adjacent, so 39 over 80. That's not the answer. So now I want cotangent. I'm going to put so cotangent of X is equal to 80 over 39. And it really is that simple, guys. What do you guys think? Pretty easy? Ask, guys. I can't read questions. I can't read questions. I can't read minds. What's up, miss? Tell me, please. Yeah. What? Like at all?
Well, it makes sense, but it doesn't.
Well, tell me, miss.
I don't even know. Like, why does it just flip? Yeah, that.
Okay. See, you gotta ask. You gotta tell me. So the question is, why does it flip? Because the question that they're asking is, what is cotangent of angle X? And if I come back to page 1, and page 1 it tells me that cotangent, here's my notes, cotangent is the reciprocal of tangent. Now remember what tangent was. Look, it says cotangent of B. Look what tangent of B was. Tangent of B was B over A. And look what happens. They flip it. A over B. See, look at this one, cotangent of A. So tangent of A was A over B. So what happens to cotangent of A? B over A. That makes sense? So, because it's a reciprocal. So, what did I do on this one, miss? I said, well, cotangent's a reciprocal of tangent. I found the tangent one. And then once I found the tangent one, I just... That makes sense? Isn't it cool? Do you guys feel your SAT scores going up? No, I'm being serious. You know how we started first period? We should have done it with you guys. Darn it. Okay. Well, okay. Take a sneak peek at the last page. We're just going to look at it real quick. We started with this. We go to first period. Read this question. Now, it's from an ACT book. And then they were like, all right, can we do it? And like 2 of them could do it. And then the rest of the class was like, I don't know. So then we did. Then we're like, all right, put it to the side. And then we did the notes. And then once we did the notes, we're like, all right, now you guys try it. And guess what? Most of them got the last one correct. So can you feel the SAT and ACT going higher? I can. By the way, guys, I don't want to just advertise myself as specifically pre-cal, college algebra, and calculus. If you have a goal for the SAT or ACT math, if you have a goal, like let's say you want to come as close as possible to an 800, come in with your SAT book, and we can do every single question you want. And I guarantee that your SAT and ACT score will go up for sure. Come in after school, during lunch, morning, whenever you have downtime, because I know everyone has issues. And then say, Mr. Chavez, I want to work on SAT. Can I bother you every time I get a question I'm stuck in? I'm like, yeah. And then you do your thing. If you're not stuck in any, you're good. And if you get stuck, just say, Mr. Chavez, I'm stuck. Like, all right, what's up? And then I'll go to the board, the chalkboard there, and we'll do it together. Or I'll tell you what question you got, and we'll do it here. Cool? So that invitation's out there for everyone, guys. All right. If you have a cousin and they want to come in, because we've had that before also where they come in after school from a different school. Yeah, come on in. The door's open. Even though your cousin, him or her, don't come to the school, if they're serious about learning math and their teacher's not helping them, tell them to come in. We've helped many kids from different schools here. Cool or not cool? All right, let's continue with the math life here. Where question do we leave off? All right, check it out. Ready, miss? You're gonna be beast on this one. It says triangle GHI, and then they give us all this information, and they don't have to, but they did. And they want cosecant of angle G. So I'm gonna write SOHCAHTOA. And I see cosecant, so the one that I should be thinking about is sine. I want sine of angle G. All right, miss, how do I do sine of angle G? I know, I'm trying to pick on you. I'm sorry, miss. Don't worry, don't feel bullied. You can use the lifeline. Sine of G, sine is what over what? Yeah, or say up, you see this right here, this abbreviation? What does the O stand for? What does the H stand for? Yeah, cool. So sine is what over what? Yes. Yeah, you're right. No, I understood what you meant. Opposite over hypotenuse. All right, here's angle G. Here's the angle. What is opposite? 12. What is hypotenuse? Yes, the hypotenuse is always the longest side, wherever this aims. 12 over 37. Now, why did I get this? Well, because cosecant is the reciprocal of sine. Yes or no? Yeah, it is. Oh, okay, so don't worry. We're going to talk about how do we know what's what. So, cosecant, here's how you spell it. CSC of G. So, what's the reciprocal of sine? Perfect. Okay, I think I read someone's mind, but I'm not sure, because sometimes I can kind of tell what question you're going to. I think I read someone's mind, and while reading her mind, I think she was going to say, how do I know what's the reciprocal of what? Was that what question you were going to? Okay, here's a hint, and it's just mental work. Ready? So let's look at this real quick. So go to your page 1, and I want you guys to just notice. The reciprocal of cosecant is sine. And I want you to notice what it starts with. Cosecant starts with the letter C. Sine starts with the letter S. The reciprocal of secant, it starts with the letter S, is cosine. What have we observed? That the letters just, it's either going to start with a C or an S. Right? So if we're talking about cosecant, oh, the reciprocal must be sine. If I'm telling you, give me the reciprocal of sine, you're going backwards, of course. The reciprocal must be cosecant. Does that make sense? Now, this one doesn't follow that rule, the tangent and cotangent, but that's because that one's a simple one. If I tell you tangent, what's the reciprocal of tangent? You're going to tell me cotangent. They almost sound the same. Tangent, cotangent. Cotangent, tangent. Does that make sense, guys? So for cosecant and sine, okay, so sorry if I'm going really fast. Hey, Graheda. So, what is the reciprocal of sine? Cosecant. What is the reciprocal of cosecant? You got the, not secant, but sine. Sine, cosine are the originals. So let's do it again. What's the reciprocal, and it doesn't matter, I know we can play with words. What's the reciprocal of cosine? Secant. You got it, miss. Good job. Come on in. No, we're doing the same activity. But you just finished the delta and we're good. Cool. See, you already got it, miss. You're already a beast. Cool or not cool, guys? All right. So let's keep going. So now you know. CSSC, they toggle. We are now on page 3, right? All right, so now they get a little harder. See, now they're getting fun, guys. These are fun now. They get a little harder, and let's read them together. And it says, given sine A is equal to 5 over square root of 9, and that angle A is in quadrant 1. What is it talking about, quadrant 1? Find the exact value of cotangent A in simplest radical form using a rational denominator. Okay, before we continue, guys, here's what they're talking about. I have a grid. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Always use Roman numerals. I guess if you use numbers, I'm not going to count it wrong if you say it's in quadrant 2 and you write the number 2. But your professor might tell you something, and if he asks you what high school you went to, just say like Jeff High School or something. It's always Roman numerals, and I'm kind of joking, but kind of not. But what's up? Yeah, go for it. All right, so here we go. So it wants us in quadrant 1, so exaggerate quadrant 1. So here's how you exaggerate it. Do you see how quadrant 1 is exaggerated? I just want to see quadrant 1. So now you're going to start at the origin, and you're going to draw a right triangle. And it's going to be perpendicular to the x-axis, like this. And you don't have to do the sound effects. There it is. There's my right triangle. That's what they mean. Well, not quite. Angle A in quadrant 1 means this is the angle that they're talking about. Angle A. So that's what they mean. So whenever you come across a question like this on the SAT, ACT, or Delta Math, we call Delta Math Delty. So whenever you see it on Delty, that's what they're talking about. Cool? All right, so now let's see what this says. This says sine A is 5 over square root of 89. We're going to pick on you one more time, miss. Don't worry, this will be the last time. Because after this, you're going to be gold. So Katoa. So because this says sine A is 5 over square root of 89, this means, where's my 5? Where's my 5? What do you think? Yeah, the opposite, which happens to be right there. What we call that is vertical displacement. So whenever you get to physics, that's called the vertical displacement. Cool? And don't worry if we're giving you guys too much. That square root of 89 is a hypotenuse. So an hypotenuse, right, square root of 89. Notice we need the base of that triangle. Cool? What can we use? Is there a famous theorem we can use? Yeah, Pythagorean theorem. So using Pythagorean theorem, can I do it in one step, or do you guys want me to show like all the steps? Yeah, let's do it in one. Okay, I'll do all the steps on this one, but the next one we'll do it in one. All right. So there's my x. That's what I want. So x squared plus 5 squared equals square root of 89. And I'll tell you what I mean by one step in a little bit. Move the 5 squared to the other side. X squared equals, oh, that's square root of 89 squared, sorry. Square root of 89 squared minus 5 squared. And then square root. And here's what I meant by one step, guys. I wanted to just write x equals square root of 85, square root of 85 squared minus 5 squared. Can we do this? Hey, come on in, miss. Can we do this by hand? Yeah, we can. What's up? I see an error. That 89 magically turned into a 80. I didn't look. This looks like it could be an 89, and then I guess I didn't recognize my own handwriting. It's an 89, guys. Let me fix it. There we go. So I got excited, probably. Square root of 89 squared, that's 89. 5 squared is 25. Can we do this without a calculator? Yes. Yeah, square root of 64. And the square root of 64 is 8. All right, here we go. Finally, what do they want? They want cotangent A. So what I'm going to do first is find tangent A. Now, if you already know what you're doing, guys, you can go right to cotangent A. Tangent A is opposite over adjacent, so 5 over 8, comma. So cotangent A is equal to, just flip it, reciprocal, 8 over 5. Done. Yay or nay? Math life or not math life? No, math life. Math life all the way, miss. All right, here we go. Is it lunchtime? We were so into this. All right, let's go to lunch, guys. All right, so we got 2 more examples left, right? And that's it. So example 6, is everyone here? Did you guys talk about math live during lunch? And I'm like, man, that's so awesome that we're learning so much math. Or you guys just...
Yeah, I told him I felt my SAT score going up.
Good. Did you really?
Yeah, I did.
Good. Thank you, miss. Are you being serious?
Oh.
Oh. Yeah, miss. You got me all excited. All right, here we go. So it says, given cotangent A is 5/2 and that angle A is in quadrant 1. So again, guys, exaggerate quadrant 1. So here's quadrant 1 exaggerated. And then we're going to draw our reference triangle. So there it is. And this is angle A right there. And then cotangent, well, I guess you can write SOHCAHTOA real quick. So then that means tangent of angle A is 2/5. So tangent, that's a 2, that's a 5. I need to figure out, before I do anything, I need to figure out what the hypotenuse is. The hypotenuse is the square root of 2 squared plus 5 squared. All I did was Pythagorean theorem, guys. Nothing crazy. Square root, 2 squared is 4, 5 squared is 25, so the square root of 29. So now we're going to go, what do they want? Sine A. So I'm going to double underline the so part. So sine of angle A, that means x is square root of 29. And I'll slow down. Sine of angle A is opposite 2 over hypotenuse, square root of 29. Now, you don't want to keep the square root of 29 in the denominator because it says right here, in simplest radical form using a rational denominator. What that means, guys, is that they want to see integer in the denominator. So we're going to multiply by the square root of 29 over the square root of 29. Now, we're not doing anything crazy, guys. Square root of 29 over square root of 29, that's just 1. So anything times 1 is itself. Are we okay? Perfect. So Chavez, why are we doing this then? Because if we do this, you get rid of the square root. Square root of 29 times square root of 29, it's the same number. So this is just 29. If you saw my video, the very first one where I did square root of happy face times square root of happy face was just happy face, it's that logic. I don't know if you guys like happy faces or not, but I like happy faces. That one looks like a evil guy. But I recently saw the movie Soul. Have you guys seen that movie? It's really cute. There's this character, his name is Terry the accountant. I don't know, I like him a lot. He's really chill. That's all I wanted to say. If you don't know what I'm talking about, go to YouTube and put Terry the accountant from Soul, and you'll see that he's a pretty cool guy. All right, given the last example here, given cosecant A is square root of 97 over 4, and that angle A is in quadrant 1. So again, exaggerate quadrant 1. So here's the quadrant 1 exaggerated, and here is my right triangle, not to scale. So cosecant is the reciprocal of which one, guys? Which one? Yeah, you said it right. Yeah, no, well, you're right. It's sin is sin, but well, sin is said as sin, but you pronounce it sine, sine. So sine A is equal to 4 over square root of 97. So if this is A, that means this has to be 4, and this has to be square root of 97. Since I am looking for the third side, I'm just going to go ahead and subtract. Chavez, what do you mean? I'm doing Pythagorean theorem. The bigger side, square root of 97, squared minus 4 squared. Square root of 97 is 97. 4 squared is 16. 97 minus 16, 97, 87, 81. Square root of 81. What's the square root of 81? 9. Now that we know that this is 9, here we go, guys. I want secant, so I'm going to write SOHCAHTOA. Secant is the reciprocal of cosine, so I'm going to write cosine first. Cosine of A is adjacent over hypotenuse, comma. So secant A has to be square root of 97 over 9. How do we feel, guys? feel pretty good about that? Okay. We're done. We're pretty much done. Go to the last page. Oh, geez. Read that. Take about 45 seconds. Well, not you, YouTube. I'm going to go ahead and edit that out. But for you guys, take about 45 seconds and answer it. YouTube, if you want to pause it, pause it. So go ahead, guys. Go for it. Essentially, guys, you're looking for which one of these statements is true. That's what you're really looking for. I would still prefer that you read the question. But pretty much when it says, which one of the following equations could be used to find theta, the angle of the ladder makes with the ground. To get theta, you have to take an inverse. But they pretty much just want an expression that is true. So look, with respect to theta, is that 10 opposite, adjacent, or hypotenuse? Opposite. What about that 7? Opposite, adjacent, or hypotenuse? Which one uses opposite and adjacent? The sine, the cosine, or the tangent? The tangent. So tangent of that angle is equal to 10 over 7. So the answer is A. How many got it correct? Yay! Did you guys get it correct? Good job, guys. So hopefully, do you guys feel like your SAT, ACT scores are getting higher?